Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. I'd like us to continue our look at fractions with this video on looking at decimal fractions. Now notice, when I was growing up, we talked a lot about fractions and decimals, like they were two different things. And years ago, someone talked about common fractions versus decimal fractions. And I really like that distinction because it reminds us that decimals are also fractions. They're fractions with denominators that are powers of 10, tenths, hundredths, thousandths, right? 10,000s, 100,000s, millions. Those are all powers of 10. And as your child gets older and develops in their understanding of mathematics, they'll be looking at those denominators in terms of positive, right? When they look at place value, they look at positive exponents, positive powers of 10, and negative powers of 10. And it goes on either side of that decimal point. So in this, that use of the word decimal fraction is purposeful because we want to keep in mind that what your child has been doing with fractions is going to apply when they're introduced to decimals. And then we can link them to the place value system. But to understand that conceptual understanding that is an important part of mathematical proficiency is going to be key here because we can link what they've been doing with common fractions. So as we go through, we want to think about that fraction kit that I looked at in other videos. You might have seen this, and we've talked about how your child would be making these probably out of construction paper. Notice that I haven't labeled my strips. That's very purposeful because once they're labeled, it becomes a reading activity for your child. They'll be able to look at a piece and know its name is 1/4 or 1/2 or 1/6, 1/8, but they don't necessarily know why. See, when I don't label them, there's embedded practice. For them to determine what the name of each piece is, they have to decide how many of those fit into a whole, and then they can name one of them. 4 of the orange pieces fit in a whole, so each orange piece must be called 1/4. See, that's part of the reason why in these videos you won't see me using commercial pieces, because many of those commercial pieces have been labeled. So it's a choice. And when we're using materials with your children, we're doing it very purposefully. We're making these choices to help make sure that your children have that optimal learning experience, can make the most sense. Not just procedural, right? We don't want to just build procedural fluency, that flexibility, but also understand the why, the how, and the models we can use. So this is one model, the area model. And as we bridge to decimal fractions, I'm going to build from this model. Then we can look at number line models later. But we're going to use this to help build the understanding of decimals. So you can see I might start your children with something like this. It looks similar to the fraction kit. I've already cut it into 10 equal pieces, and we might ask your child to color in a different number of squares in each one of these. Now, I'd like you to notice that I don't have these colored in some precise way. It's precise, but what I mean is I don't have sequential squares colored in, right? In that first one, 3 of the squares are colored in, so I know that's 3/10. If you look at the second one, I have 3/10 above a square and 3/10 below, so that together makes 6/10. Nothing says that when I color in the squares, when I shade in, I must shade sequential, those consecutive squares. So your child starts out, they might color in a different number of squares in each one of these, and then they label them. Now, we've already been working with common fractions, so notice this common fraction label is where we start, and then all we have to do is do the equivalent decimal fraction label. Now notice I don't have zeros in front of the decimal point. It's not mathematically required. It can be helpful. I know that my teachers wanted me to put it in so they knew there was a decimal point there. But mathematically, it's not required that we put the 0 in front. So you may see it either way, and both would be correct. Now, I have my common fraction, I have my equivalent decimal fraction. And that should help your children understand that we're not really looking at a new concept, we're looking at specific denominators. Now, I can transition them from this long rectangular one that looks like the fraction strips they've been using to a different whole. In this case, our rectangle is actually an equilateral rectangle, a square. This one has been divided into 10 equal sections. I can do the same activity. Color them in a different number, right? A different number of rectangles, sections in each one, and then let's label them. Again, we want to label with both common fraction and decimal fraction so that they see the connection. And also, it's important that your children read them the same way. If I look at the first one, it's 3/10 as a common fraction and it's 3/10 as a decimal fraction. Many children shift into reading symbols, 0.3, 0.5, 0.1. That isn't going to support the link to place value we want them to have and the connection to the common fractions. Now, sometimes the teachers may say, "What did you write?" And they will say 0.3. Fair enough. But when I read it, I really want them to use the fraction names, right? That decimal, 3/10, 5/10, 1/10. Okay, so that's important to help your children when you're helping them at home. Read those decimals correctly, not just name the symbols they see. Now, I can start here with coloring in half of it. See, we're linking. I've changed the look of the whole to that square. I could ask your child to color in half of it. So they shade in half of it. Now, what's another name? See, I can start to build those equivalencies by coloring in half. What's another name? 5/10. What's another way I could write that? Still 5/10, but as a decimal fraction. And then what we also want to help your child understand is, what if I cut my whole into 100 equal pieces instead of 10? Can you picture sliding that over? And do you see now that that 5/10 is equivalent to 50 hundredths? Okay. So I could write that also as a common fraction. In the same way, so I could have written this as 50 over 100, 50 hundredths. Now that's the same idea. Notice how I made a big point of saying don't read it 0.5 or 0.50. Read it 50 hundredths, 5/10. Same is true about 5 over 10. Have them read it 5/10. Name that denominator, or 5 1/10 pieces, as I've been sharing in other videos. It links to that unit fraction size, tenths, and it tells me, that numerator tells me how many of them I have, 5 1/10. Okay. Now, in the same way, we could look at a quarter, the decimal equivalent. Okay. Now, I hope you see I'm not reverting to long division to divide 1 by 4. That was a technique that I used when I was in school, and that's a technique they may use as they go up through the grades. But it's not required to build a link between common fractions and the decimal fractions. See, I start with that 10 by 10 unit, and I can cut it into 4 equal pieces. And your children may do it in different ways. But if I cut it this way, this to me is a simple enough way to do it, and then I look, do you see how I can see in each section there are 25 100th pieces? And I could have written that, I wrote it as a decimal fraction, I could have written it as a common fraction first. As many links as we can make, it's important. And I kind of previewed. Notice how I could put the 0 in, but it's not required. Mathematically not required may be helpful to help us see that the decimal point is there. Okay, so same idea, doesn't change when I look at that 0. Now, it's about flexibility and reasoning, understanding in a way that I can do much of this in my head because I get what's going on. Now think about, for each of these blanks, pause the video and fill in the blanks if you will. what do you think would go in each one? And reason through it, right? So if I want to write decimal equivalents or if I want to write the fraction equivalents, pause and try it, come back, we'll look at it. Now notice this first one, you want to make sure your child understands that they use the word and when they see the decimal point. It's also important for your child to understand that different regions of the world use different symbols for a decimal point. Here in the US, we use the point, the period. In Europe, they would use a comma. Okay, other places use a comma where we use it. We are sticklers here in the US for only using the word and at the decimal point. Other places aren't as rigid in that use of that word and. So for us, this next one would be 1 and 25 hundredths versus 1.25, right? 1 and 25 hundredths. What's another way we could write 25 hundredths? We've looked at that equivalency above. So 1 and 1/4 would be equivalent to 1 and 25 hundredths. 6/8. Well, if I've done enough with those fraction kits and I've worked through equivalencies in terms of number lines and same size pieces and all of that, I know that 6/8 is the same as 3/4. Well, if 1/4 is 25 hundredths, what would 3 of those be? See, it lets me go through that reasoning, and I know I don't have to immediately go to long division. I can reason through what the decimal equivalents are. And these are important benchmark numbers to keep track of. They help us when we're comparing fractions, when we're doing other work with fractions, is keeping in mind those relative size and keeping in mind the connection and making that very strong with what all that work we do with common fractions. I hope this helps in a way that we can introduce your children to decimals and decimal fractions. If you would, please consider subscribing to the channel. It is so very helpful. I do appreciate it. If you do, click on the notifications bell so you'll know when others' videos become available. Also, I hope this was helpful. If you would, give it a thumbs up, share with others. All of those things help this channel to grow, help us to maintain. And as I said, I really do appreciate your support. Thanks so much for watching.